Okay, in this video we will discuss the measurement of gear, that is module number 3 chapter number 2. So in this video we will discuss the introduction of the gear drive, advantages and disadvantages of the gear drive and terminology of the gear. So basically we know gear drive is a positive drive and it is provided when the distance between driver and follower is very small, and the gears are basically and also gears are defined as toothed wheels which can transmit power and motion from one shaft to the another shaft by means of successive engagement of the teeth. So this is the definition of the gear, and it is very important that both the gears which are engaged always rotate in opposite direction. That is very important. And the gear drive, it consists of a two wheels. So a small wheel we can call it as a pinion, and a large wheel we can call it as a gear. This is about the introduction of the gear drive, and just orally I will tell it, read it out the advantages and disadvantages of the gear drive. Basically the gear drive, already we know that it is a positive drive because it is having no slipping takes place in the gear drives, so only we can call it as a positive drive, and it transmit a exact velocity ratio, and it can transmit large power with a low velocity, and it has high efficiency and reliable also, and it can be used to transmit power between the two shafts which are parallelly intersecting or non-parallelly and non-intersecting. So and it can be used for changing the speed ratio over a wide range. So for that reason, because of these advantages, we are using a gear drives. And the main disadvantage is that the manufacturing process of the gear is complicated, and the cost of the gear manufacturing cost is also high because it requires a special tools or cutters for the manufacturing of the gear drive. So it requires a precise alignment of shaft. That is the main disadvantage of the gear drive, and also to get a very long life of gear tooth, so it requires a lubrication system for a smooth operation. This is about the disadvantage of the gear drive. Now we will discuss the terminology of the gear. The basic terminology, it contains some different some different terms, different basic terms used in the gears, that is pitch circle diameter, pitch surface, pitch point, module, circular pitch, diametrical pitch, pressure angle, addendum circle, dedendum circle, clearance, total depth, working depth, tooth space, tooth thickness, face of the tooth, flank, face width, backlash, speed ratio, so and so. So these are the basic terms which are used in the gears. Just I will show the terminologies used in the gears by writing the figure. Based on that figure I will explain all the terms one by one. Now just I will write the terminology used in the gears by writing the figure. Initially first write down this one space. This is what the flank. This is what the root or a dedendum circle. This is root or dedendum circle. Next, above that one we are having a clearance here. So this is what clearance or working depth circle. Now I will write the pitch circle. This is pitch circle. So this is face width. I will write it down. So I will show the face. This is what the face. This is what the top land. This is what the pitch surface element. Pitch surface element, and this is what flank. You already know in the screw threads in the previous chapter. This is what the face width. This is what the face width. Now I have to write a addendum circle here that will touches the top. This is what the addendum circle. This is what the pitch circle. Below this one we can call it as a what? Dedendum circle. Already we have written here. Dedendum circle, root or a dedendum circle. This one. Above this one, this is pitch circle. This is addendum circle. Below is what? Below only we can. This is root or dedendum circle. Above this one, work depth or clearance. So the distance between these two. So this is what the clearance. So the distance from dedendum circle to the pitch circle, this distance we can call it as a dedendum. So from the addendum circle to the pitch circle we can call it as a addendum. So the overall we can call it as a tooth depth. From here to here we can call it as a tooth depth. And here from here to here, this is what a tooth space. From here, from this point to this point, this distance we can call as a circular path. Circular pitch, not path, circular pitch. From this point to this point, this is tooth thickness. This is about the figure related. It will covers all the terminologies used in the gears. Just I will explain it out, and also I will show another one circle gear mating point. Which one is the I already told you the gear drive consists of two wheels. Just I will write out the two wheels. One small wheel and another one is a big larger wheel. Small wheel we can call it as a pinion, and a larger wheel we can call it as a gear. Just I will show it. just here. Above this circle. This is what a addendum circle above this point, and below here this is what a dedendum circle. In between you will write a pitch circle. That is a here mating point. The two gears. So this is a pitch circle. This distance from here to here, this is what a pitch circle. From above this point to this point, outer circle we can call as addendum circle, inner circle we can call as a dedendum circle. Here also this mating point, the point we can call as a pitch point. Above circle here we are drawn here, and through the pitch point enter. Just I will write a rough diagram. Below this line, dedendum point. Both should be in the opposite one direction, that is very important. This is pinion, this is gear. The distance between these two, is dedendum, and distance between these two, above, middle with the above, is what? Addendum. So this is about the figure related to the terminologies used in the gear. So just I will explain it out one by one. What are the basic terms used in the gear? Just I will read it out, explain it out one by one. Now, so here we are using a pitch circle. Here we are used a pitch circle. We know the pitch circle, it is a imaginary circle on the gear. Where you are used here pitch circle, here this line, middle in between the both addendum and the dedendum. It's an imaginary circle on the gear, which by pure rolling action would produce some motion as a actual gear. So pitch circle diameter, that is pitch circle diameter is generally the size of the gear is specified by the pitch circle diameter, with it is represented by a small d. It is represented by a small d, and the pitch surface, it is a surface of the rolling disc which the toothed gear has replaced at the pitch circle. That surface we can call it as a what? Pitch surface. And the pitch point, the point of contact between the two pitch coincide the circle. I have shown here. So these two gears which are the two pitch circles of the mating gears, pinion and the gear mating point, that point we can call it as a pitch point. So and the module M, it is a ratio of what? Pitch circle diameter of the gear divided by number of the teeth on the gear, that is d by z. And it has some standard values of modules are there. So some second choice, first choice is there. So the module specifies the size of the gear tooth. If the module increases, the size of the gear tooth also increases. That is very important. The standard values can be that can be recommended by ISO in terms of that Indian Standard of Organization, that is with the dimensions in mm. And related to the circular pitch, this is related to the module, and the circular pitch is the formula, is the distance between the distance measured along the circumference of the pitch circle from point of one tooth to the corresponding point of the next tooth. That is the circular pitch we are measured here. and that is represented by PC. That is represented by PC, that is equal to pi into d by capital Z, that is equal to pi d by Z represent a module m. So that is pi into m in terms of it is denoted by PC, and a diametrical pitch, that is PD, that is Z by, there is a ratio of what, number of teeth, that is Z to the PCD in the mm, that is a pitch circle diameter, that is small d. So one, it is a inverse proportion of the module, that is 1 by m, we can call it as a, and the pressure angle between the common normal drawn at the point of contact of the mating gears and the common tangent at the pitch point. This is, it is also called as angle of obliquity, that is denoted by phi, that I will show it in the involute profile. It can be ranges from 14.5 degree, and the standard value of the pressure angle it is by 14.5 degree and the 20 degree. This is the pressure angle, standard value of the pressure angle. And the addendum, the radial distance of the gear tooth from the pitch circle to the top here, pitch circle to the top, this is the addendum. And also in the circle also we have shown here above the pitch circle, and below we can call as a dedendum. That circle we can call as addendum circle, below which circle we can dedendum circle. In between these two, the pitch circle, there the mating points of the two gears going to happen, that point we can call it as a pitch point. And the clearance we can call it as a what, it is a radial height difference between the addendum and the dedendum of the teeth. And the standard teeth clearance is what, 0.157 m in terms of meter, that denoted by C suffix capital L, that is HF minus HA, that is height difference of the height difference between the addendum and the dedendum of the teeth. That standard value is what, 0.157 meter. So the total depth is what, addendum plus a dedendum, and we are having a working depth, it is a radial distance between the addendum circle to the clearance, as shown here on working depth. Here working depth circle is there, and also I have shown here circular and the tooth thickness, the thickness or the width. Here I have shown here tooth thickness, there is a width of the tooth measured along the pitch circle. So this is the pitch circle, it is measured on the pitch circle, that the width we can call as a what, tooth thickness. And the tooth space, the gap between the gap or a width of the space between the two adjacent teeth, from one teeth another, that the gap between these two, the space we can call as a what, tooth space. So that is also over. And the face of the tooth, the part of the top surface above here, face above face we can face of the tooth, and flank of a tooth here, that we have shown here, this part we can call it as a what, flank, and this part we can call it as a face. And the width of the gear tooth measured parallel to its axis, that width we can call it as what, face width. Here this is the width, face width, the width of the gear tooth, this is one gear tooth measured parallel to its axis. This is the axis, this is measured parallel to its axis, we can call it as a what, face width. And the backlash, and the one term is there, terminology is the difference between the tooth space and the tooth thickness, which is measured along the pitch circle, that is we can call it as a what, backlash. Once again I will repeat it out, the backlash, it is a difference between the tooth space and the tooth thickness, this minus this, we can call it as a what, backlash. And another one term, speed ratio or else velocity ratio or gear ratio, this is very important for the design of gears. So here we represent speed ratio, or we can call it as a velocity ratio also, gear ratio also, all these are same only. It is defined as a ratio of pinion speed to the gear speed, or else it is a ratio of number of teeth on the gear to the number of teeth on the pinion, or it is a ratio of diameter of the gear to the diameter of the pinion. Here we will see here, this is the, you can see here the definition. So it is a ratio of number of teeth on the gear to the number of teeth on the pinion. Here number of teeth on the gear and the number of teeth on the pinion. and also it's the ratio of the diameter of the gear to the diameter of the pinion. It's the ratio of the pinion speed to the gear speed. We can write it any definition related to the this one. If it is related to the speed, it is related to the diameter, it is related to the teeth. So this one we can call as the gear ratio, speed ratio, or else velocity. If it is related to the velocity, we can take it as a n. If it is related to the gear ratio, if it is respect to the speed, n. It is respect to the velocity ratio, also we can write it as a diameter of the gear to the diameter of the pinion. So and with respect to the teeth, number of the teeth on the gear to the number of the teeth on the pinion. So and also, and the next and the last terminology left it out is what? Center distance. So center distance is the distance between the axis of the two mating gears. So distance between the axis of the two mating gear, it is given by the center distance, that is dp plus dg divided by 2. dp represent what? Diameter of the pinion and diameter of the gear. So we know that module we have shown here. We have shown here, yes, here circular pitch, the PC is equal to pi into m, that is m is equal to d by z. So d is equal to z into m. We have written here module. We know the module is equal to pitch circle diameter divided by number of teeth. So so diameter is equal to what? Pitch circle the module into number of teeth. So m into zp into m into zg divided by 2, and finally we will come to the expression, that is cd is equal to m into zp into 1 plus g divided by 2. This is the formula for the center distance. This is about the terminology of the gear. It's very important for your mechanical future. Thank you.